Let's just jump right into this explainer, shall we? Today, we're looking at how the HATS protocol is completely transforming decentralized organizations into programmable digital objects. Look, if you've spent any time working in a DAO, you already know managing roles and permissions can get incredibly messy. Just picture your typical DAO Discord server, right? It's usually a chaotic mix of overlapping channels, totally ambiguous leadership, and just endless debates over who actually has the authority to execute a simple treasury transaction. Because, when everyone is supposedly in charge, absolutely no one is. And that ambiguity, it completely paralyzes projects. But we're currently looking at a massive paradigm shift in how we structure on-chain identity and authority. We're finally moving away from abstract social coordination, where people just kind of assume roles based on vibes, to hard-coded, perfectly legible organizational graphs. Decentralized governance is inherently chaotic, and this really hits hard once an organization crosses Dunbar's number. You know that famous cognitive threshold of around 150 people? That's where human social memory and casual coordination just completely break down. You can't rely on just knowing everyone to get things done anymore. And in the digital world, slapping a Discord admin title on someone means absolutely nothing on the blockchain. It's not going to stop them from running away with funds, and it definitely doesn't give them the programmatic power to actually govern a protocol. So this leads us to a massive question. How do we create clear, enforceable roles that actually mean something on chain? How do we build an organizational chart with actual teeth, where a role isn't just some purely social title, but an ironclad programmatic set of permissions? To answer that, here is our agenda for today. We're going to cover 1. Moving beyond global identity. 2. Local authority namespaces. 3. The hierarchical bitmap tree. 4. Programmable role-based access. And finally, number 5, real-world DAO applications. So let's start right off with Section 1, Beyond Global Identity and Transitioning from the Who to the What. To really grasp this transition, we've got to look at how we currently treat identity in Web3. Usually, we think of it through the lens of ENS, the Ethereum name service. ENS acts as your persistent global passport. It's totally user-owned, it travels with you everywhere you go on the internet, and it represents the who. But managing an organization requires a completely different toolset, and this is where HATS protocol flips the script. HATS functions as your instantly revocable company badge. It defines the what, as in what you are actually authorized to do. Think about it in the physical world for a second. You wouldn't use your international travel passport to unlock the office supply closet on a Tuesday morning, right? No, you'd use a company-issued keycard. That keycard is a non-transferable token that you wear rather than own. It grants you access strictly where you need it, and, crucially, it can be deactivated the absolute second you leave the building. Which brings us to Section 2, Local Authority Namespaces and Defining the Framework of Control. This whole concept of defining what you can do, rather than who you are globally, is built on a specific piece of infrastructure, the Local Authority Namespace. Simply put, this is a structured on-chain environment where roles, permissions, and authorities are delegated locally within an organization's specific context, rather than universally across the internet. Let's make that a bit more concrete. If your DAO has a treasury fund, the namespace is essentially just a fancy way of drawing a digital border around that treasury and saying, hey, inside this exact border, the person wearing this specific hat holds the keys to the vault. Outside of that border, the hat is literally meaningless. So the protocol is providing a highly specific, programmable role within a single organization rather than a universal web identity. Basically, if ENS is your legal name, your hat is your job description and your keys to the office. When you step back and look at how this reshapes governance, it hits you that HATS protocol is essentially the unstoppable API for programmable organizations. By treating these roles as the atomic unit, like the foundational building block of an org, HATS lets DAOs program themselves with all the insane benefits of smart contracts, total autonomy, and composability. You're no longer just assigning a title on a spreadsheet anymore. You are actually instantiating a functional software object that bundles responsibilities, permissions, and accountability all into one single wearable asset. Okay, moving to Section 3, the hierarchical bitmap tree, where we'll be visualizing the math behind all of this. The core mechanism making this all possible is purely mathematical. Now, storing complex organizational structures on the Ethereum blockchain can be astronomically expensive if you do it wrong, but HAT solves this so elegantly using a 32-byte ID. Think of this 32-byte ID as a digital map. The first 4 bytes represent the top hat, basically the CEO or the absolute root of the organization. Then, each subsequent 16-bit chunk of data represents the next tier down. So department heads, managers, individual contributors. Because the entire administrative lineage is baked directly into the bits of the ID itself, smart contracts don't need to do these super expensive recursive lookups to prove who is in charge of whom. The hierarchy is structurally legible at a mere glance by the blockchain. This saves a massive amounts of money on transaction gas fees, because the chain instantly knows your exact position in the company just by reading your ID. And the scale of this mathematical tree is honestly mind-bending, because each of the 14 sublevels within that ID contains 16 bits of space. A single HATS tree has a staggering theoretical capacity of 2.696 times 10 to the 67th power. Just let that sink in for a second. That is a number well beyond the total number of stars in the known universe. Every single node in this organizational tree can have over 65,000 immediate child roles under it. You could meticulously map out the most complex, massive global corporate hierarchies known to mankind, every single employee, every contractor, every automated bot, and you would literally barely scratch the surface of a single HATS tree's total capacity. It's wild. Let's jump right into Section 4, Programmable Role-Based Access, or what we like to call roles with teeth. It's one thing to have a neat organizational chart, right? But it is entirely another to make it functionally enforce role-based access control, or RBAC. The crucial takeaway here is that this lifecycle guarantees power is tied directly to the role itself, not the individual human being holding it. First up, mint. An admin hat mints a token which is similar to a standard ERC 1155 token format directly to an eligible wallet. Next is grant. The wearer of that token instantly gains whatever specific authorities are attached to that hat. That could be signing off on funds in a highly secure Gnosis safe, or it might just mean getting access to a token-gated workspace. But then comes the most important part, revoke. Just as easily as it was granted, an admin hat can instantly revoke that token, yanking those permissions right back. This instant revocability is exactly what gives the organizational chart its actual teeth. It's what makes role-based access control completely trustless. In traditional DAOs, trying to remove a malicious or inactive actor from a multi-signature vault can be a total logistical nightmare. We're talking complex votes, slow transitions, the whole 9 yards. But with hats, you can simply snip off rogue branches. The hat is mathematically burned, and because all of their permissions were tied exclusively to the hat and not the person, those powers are instantly revoked. And the best part? All of this happens without destroying or disrupting the rest of the organizational tree. That is a massive wave of relief for DAO operators who've historically struggled with managing rogue members.
Finally, we arrive at Section 5, Real-World DAO Applications, featuring Purple DAO and Liechtenstein.
Now, this is a brilliant architecture in theory, for sure. But to truly understand its impact, we have to see how it's performing in the wild. Take Purple, for example, a DAO built within the Nouns ecosystem. Chris Curella, the founder of Purple, highlighted the absolute stark difference hats made for them. Before implementing the protocol, they had stagnant, unremovable members just sitting on multi-signature wallets, holding all the DAO's funds, huge security risk. Hats allowed them to transition completely away from that. As Curella put it, now with Hats, we vote as a DAO for who should be on the multisig, who gets replaced on it, and who is entrusted with leading our various initiatives. The operational results for Purple were pretty dramatic. By utilizing Hats, they achieved an incredible 80% reduction in proposal time across the DAO, all while significantly tightening their security. They pulled this off by running fully on-chain elections using Joke Race, which is a platform specifically designed for executing on-chain governance contests. But here is the absolute killer feature. They built in automated term limits tied directly to these roles. So when a representative's term concludes, a mechanistic toggle instantly burns their hat. It automatically revokes their veto powers and triggers a brand new election. No middlemen required, no trust needed. It is literally just code executing the explicit will of the organization. We're even starting to see highly advanced fusions of this technology in the broader ecosystem. For example, Island Hats and the ERC 7827 standard are currently combining the global naming power of ENS with the granular role management of hats. They do this using something called semantic containment. Basically, in simple terms, they're looking at the foundational code of an ENS name and using specific text triggers, these are known as ASCII prefixes, to automatically derive and grant authority. So instead of needing a complex separate system, it's fusing your global identity, the who, and your local role, the what, right down at the most foundational machine level of the blockchain. And zooming way out to a macroeconomic scale, we're actually seeing these exact same design principles being applied to national law. Take Liechtenstein's token container model, for instance. Under their Blockchain Act, tokens legally function as containers for real-world civil rights.
The token is quite literally just a container, in exactly the same way that a digital hat is a container for an organization's specific DAO permissions. Protocols like QGov are actively operating under this legal framework, utilizing physical validators to bridge digital and real-world assets. It perfectly mirrors the heavily rule-bound nature of the hat's hierarchical tree, but applies it directly to institutional finance and global property rights.
As we transition deeper into an era of agentic networks, where smart contracts, human workers, and AI agents are all executing complex tasks together seamlessly, we're left with a fascinating thread to pull on. How will these programmable, instantly revocable roles ultimately redefine cooperation across the open internet? When authority can be granted, executed, and revoked in a single block without any human intervention, what will your organization's tree look like? And perhaps more importantly, who or what will be wearing the top hat?